So I guess we can start now. So hello everyone and welcome to today's event on the lithium-ion battery industry panel discussion, which is hosted by the University of Waterloo Electrochemical Society. So I'm Moin and I will be co-hosting this event with Vipin Kumar Singh. So I just have two quick announcements before we start the event. So University of Waterloo Electrochemical Society would like to introduce its new team members in the executive team. So we have Muhammad Ali Ahmadi as our outreach coordinator, Vipin Kumar Singh as our media chair, and Elizabeth Esther Miller as our treasurer. So the second announcement is for all the chemical engineering graduates in our audience. Please note that this event can be counted towards your seminar attendance. So stay tuned till the end of this event, as we will release the online seminar code 15 minutes prior to the end of this event. So now let's move on to the main event. So I'm really excited to have today's guest. So our today's guest is Dr. Loubna Ouatani as a CPO of Echion Technologies, Chris Biederman, CTO of Lifecycle, and Dr. Ravi Kempaiah, co-founder of Zen Bikes. So just to quickly introduce your companies and what they do. So Echion Technologies supplies high power lithium-ion battery anode material that enables fast charging and low cost of ownership. Lifecycle recycles the end-of-life lithium-ion batteries and supplies the recycling materials to the battery market. And Zen Bikes is in a mission to produce high-quality net zero emission alternatives for urban transportation and energy storage product using battery technology. They provide a line of electric bikes in their product line. So as I understand, our guests have quick introductory presentation. So I will ask them to present them in order before we move on to panel question and answer section. So if I guess Dr. Loubna can start first.
Yes, so thank you first. Do you hear me well first?
Yes, I can hear you.
Yeah, perfect. So thank you very much for inviting me for this event. It's a big pleasure for me. And yes, so who I am. So I am, do you see my, maybe the presentation is, yeah.
I can see your screen just fine.
So, okay, so today I'm the Chief Product Officer at Echion Technologies, and my background, let's say I'm originally from Morocco, so I left Morocco in order to do my master and engineer degree in France. And after that, I have done my PhD in lithium-ion batteries. So a very technical background, I would say. And I kept the lithium-ion batteries and I moved to an industry, to a company called Saft, which is in France, but also in US and India. So, and I have done almost more than 12 years experience there in lithium-ion batteries in different applications, space application, grid application. And during my time there, I have decided to do an executive MBA. And of course, also I'm a mom of two wonderful boys at the same time. And during my executive MBA as well, I wanted to have more challenge in my career, and wanted to be having a big view of big companies and global companies in terms of finance, marketing, production, and everything. So this was one of my objectives, and due to that, afterwards I have decided to join Echion, which is a startup. As in the beginning, I was the director of products, and now today I'm chief product officer. So, and Echion, to introduce a little bit Echion, what it's doing now. So Echion is a startup company founded in 2017. And we are developer and supplier of battery active material for high power performances batteries. So in the market, we can find different anode material, graphite and silicon and LTO cells. Each material has its advantage, but Echion material has a unique advantage in terms of having a anode material that enables safe batteries with longer life, high power capability, combining the power capability and also the energy density at the cell level. We deliver material. We have begun in the beginning when I joined Echion. It was when we deliver material, it was at the gram level, and today we can deliver at the ton level scale. Yeah, so thank you very much again, and nice to meet you all.
Yeah, thank you very much, Loubna. So now I'll ask Dr. Chris, Chris, if he can present his bio.
I can do. Just give me a moment while I share my screen here. So I'll go through this fairly quickly. Just first and foremost, thanks for the invitation to speak with you all today. My name is Chris Biederman. I'm Lifecycle's Chief Technology Officer, and I'm a professional engineer in the province of Ontario with 15 years of process engineering experience. I'm a graduate from the University of Waterloo's Chemical Engineering program back in 2008. Throughout my career so far, I've led a number of projects, both large and small, in the mining industry. I've been responsible for overseeing bench scale testing and pilot scale testing, more specifically now with Lifecycle. And at the company, I'm responsible for our intellectual property portfolio, so all the patents and provisional patents we're working on, the development of new technologies at the company, that's our research and development work, and also oversight of our capital projects. So as you'll see through this quick presentation, we have a number of projects on the go and a couple of core technologies that we're working to commercialize. From an overview of Lifecycle, I think this slide sums up very succinctly what we do. So we look at end-of-life batteries, particularly lithium-ion batteries, as a resource and not as a waste. So our objective as a company is to recover the critical materials within lithium-ion batteries or manufacturing scrap materials and reintroduce them back into the supply chain. So this photo you're looking at is from our Spoke facility in Rochester, New York, and that's actually where I am today. It's showing battery cells, lithium-ion battery cells, going up the conveyor and about to be pre-processed through our Spoke facility. So this is the first step of our process, and I'll speak to the second one in subsequent slides, but it gives you an idea that we're a commercial company now, and we are in fact recycling lithium-ion batteries today. This slide is really a description of why the company exists. So the numbers don't get caught up on the gigawatt hours per year, but look at the size and the exponential growth of over the last 10 and then looking forward into the next 10 years on lithium-ion batteries within the economy. So back in 2010, you're roughly 4 gigawatt hours per year. Fast forward 10 years at 2020, you're at 250. Go another 10 years to 2030, and you're in the 3,000 range or more. So it goes to show that lithium-ion batteries are being used more prevalently in society and for different uses. And our co-founders for Lifecycle looked at this and said, well, what do we do when these uses reach the end of their life? So what are we doing with the batteries? How are we getting those materials back that are non-renewable? And we've then developed a core technology suite, which I'm showing on this slide, and we won't go through it. It's a very engineering-based flow sheet slide, but really the essence of this slide is to show we've got 2 pillars of technology that allow us to intake batteries or battery manufacturing materials, do a pre-processing, which is in our Spoke. It's highly mechanical, and ultimately derive what's called black mass. That's the anode and the cathode material in a battery, and we take that to centralized hubs. Those are hydrometallurgical facilities, so wet chemistry, if you will, at a large scale, and we produce all of the materials you see there, with the intent of pushing them back into the supply chain. So we are commercial, we are running Spokes, we are actually just constructing our first hub in Rochester, New York now as we speak. So moving very quickly to being a producer of these critical materials to get them back into the economy. I'll stop there. I'm happy to answer any questions at the back end of the panel discussion on Lifecycle if there are any.
Thank you very much, Chris. That really sums up what Lifecycle is doing. So Ravi, Dr. Ravi, if you can.
Sure. First of all, thanks for the invitation, Vipin and other hosts and moderators. It's a real pleasure to be part of this, and greetings to other presenters as well. Today, I'm going to share a little bit about my company and my background, and then why I started the company. So let me fire up the presentation here. Okay. So my background, actually, I went to University of Waterloo in 2010. I got my master's there. I worked on graphene oxide with Dr. Vivek Maheshwari in chemistry department. And then I moved to University of Maryland, where I did another master's in materials chemistry. And then for my PhD, I worked on first principles DFT investigation of lithium intercalation in MnO2 cathodes. This was done at the University of Illinois, Chicago, and also Oregon National Lab. That's my background, research background. And then right before I started my PhD, I had this 2-month summer gap, and I had always been an enthusiast biker. But in 2016, I used my e-bike to ride across the continent, the US especially, and we did 8,200 kilometers on my e-bike. And when I did that, I realized it only cost me $6 of electricity to go 8,200 kilometers. And that ride eventually became the Guinness World Record for the longest journey on an e-bike. And I realized, wow, this is a game-changing technology, and we got to get into it. And I switched from doing nanomaterials and graphene to lithium-ion batteries, and I worked on manganese oxides. And then on the right, what you're seeing is basically it costs $2 in today's gasoline cost. The prices are crazy. And then for every 10 kilometers, a typical car puts out about 2 kilograms of carbon dioxide. But if we switch to an e-bike for the same local trips, 10 to 20 kilometers, you go to 0.01 cents of electricity, and then for 10 kilometers, and then you put out maybe 9 to 10 grams of carbon dioxide, even if you power an e-bike with the worst efficiency coal power plant. So then it really changed my mind. Wow, I always thought I was going to go work for a national lab at Oregon or Los Alamos, Sandia, Lawrence Berkeley, somewhere, be a researcher. Then I got to meet with, in 2019, I got to meet with Professor Jeff Don. And I really liked his work and the impact it had. So after my PhD, I moved to Dalhousie University, where I'm a postdoc. But then most of my work is based on scaling up the company, which is called Zen Electric Bikes. And I'll share what we're doing with Zen. The goal of Zen Electric Bikes is to enable long lifetime batteries for electric mobility, especially in the e-bike world. As you can see, a good battery costs about $2,000 per kilowatt hour in the e-bike world. On the lower end, it costs about $1,200 per kilowatt hour, and you get 1-year warranty. A good one, maybe 2-year warranty, and they have a lifespan of 2 to 3, maximum 4 years. What it means is that this year alone, globally, 40 million e-bikes will be sold, electric scooters, electric bikes, and in the cheaper ones with shoddy, quality control, they will go to battery waste. It's a huge problem, as Chris was mentioning. There's a big resurgence in recycling. So
excuse me, Ravindra. Sorry for the interruption, but we can only see your first slide. We cannot see for the slides. Sorry for that. I'm really sorry for the interruption. Yeah.
Okay. Sorry.
Yeah. Now we can see. We can see that now.
Okay. Yeah. So sorry about that. A couple of minutes, I'll go back again. So yeah, in 2016, right before I started my PhD, I did this ride across the continent. Starting from Madison, Wisconsin, I biked to the border of US and Canada near Thunder Bay, and then North Dakota, then South Dakota, Mount Rushmore, Badland National Park. I biked to Rocky Mountains in Denver, and then up Wyoming, Grand Tetons, Yellowstone, Glacier National Park here, and then Idaho, Pacific 101, Redwood National Park, and then all the way to San Diego. So this was 8,200 kilometers, which was officially recognized in 2017 as the longest journey on an e-bike, continuous journey in 34 days. And I did the math. Every day I was charging my batteries 3 times. And then I did the math. It came out to be $6 of electricity to 8,200 kilometers. I thought, my God, this is really game changing. I got to get into this. So that's when I shifted from nanomaterials, graphene stuff to lithium-ion batteries. And this is the numbers that you see. $2 per liter in today's world puts out about 2 kilograms of carbon dioxide. But if you switch your local trips to e-bikes, they're super efficient, 1 to 2 cents per 10 kilometers, 9 grams of carbon dioxide. So this is the kind of numbers that the government is really beginning to notice. And that's why we got funded by STTC, which is one of the government agencies that fund startups. And then, the mission of Zen Electric Bikes. So before I started the company, I had been in touch with Dr. Jeff Down at Dalhousie. He's doing amazing research in partnership with Tesla. And we did the analysis here. So a good battery, e-bike battery costs $2,000 per kilowatt hour. And as I said, inexpensive ones, $1,200, but they only last 1 to 2 years. Globally, this year, 40 million e-bikes will be sold. That means by 2025, the world has to deal with 120 million kilograms of battery waste or electronic waste. It's huge. That's why even JB Straubel, Redwood Materials, is teaming up with e-bike companies to solve this problem, because it's a quick turnover. A typical Tesla or a Prius, you're paying about $300 to $350 per kilowatt hour, and you get 8 years of hybrid battery or battery pack warranty. In the e-bike and the electric scooter world, you are paying 4 times more, you get 4 times less warranty. It's a problem. So currently we are working on commercializing the battery tech from Dr. Jeff Down's lab. So some of the data that was published in the Journal of Electrochemical Society, and you might have known the recent report where he published 3.8 volt cell lasting 100 years at 25 degrees Celsius, which became a news. And also a few years ago, there was a report on Tesla's 1,000,000-mile battery pack. They use single crystal NMC cathode, and this is at 40 degrees Celsius, CO3, 10,000 hours, okay? And if you use it just a couple of hours a day, that's almost, at 25 degree, 30 degrees Celsius, you're looking at least 5,000 cycles easily. And we have cells in Dr. Don's lab where I work as a postdoc. We have cells that have done 15 to 17,000 cycles. And this is at 25 degrees Celsius, going all the way to 4.2 volts. Even some cells that are charged to 4.3 volts, they go 4,000 or 5,000 cycles. And if we commercialize those kind of cells for micromobility and e-bikes, then we are looking at 5,000 cycles. Then we increase the recycling interval by 3 times. That means lesser mining. I don't have to worry about battery electronic waste and then battery waste. And also the cost of ownership for the owner goes 3 times lower. So this is what we are trying to commercialize at Zen Electric Bikes. And when Biederman reached out to me, and I was happy to be part of this, because at one point I thought I would become a faculty member, and then I thought I would become a research person. Now I've ended up as a CEO of a company building this in Halifax, Nova Scotia. So I'm happy to share my experience and my journey and anything that we do at Zen. Thank you.
Thank you, Ravi, for your presentation. I guess really interesting, because in today's guest, we have, as Ravi has mentioned, we have an increase in demand for lithium-ion batteries. It's going to continue over the years. So, and then we need to recycle it and make it as efficient as possible. So I found it very interesting. So I'll hand it over to Vipin for the question and answers. Start the question and answer session.
Thank you, Moin. So I hope you can hear me well, all of you. So yeah, so thank you all for the great presentation. So now is the time for the technical questions based on lithium-ion batteries. And to begin with, I would like to ask all of you. So there are a lot of companies nowadays working in the lithium-ion battery industry. So how do you differentiate your company or technology from others in this space? Dr. Loubna, you can start first if it's okay with you.
Yes, I can start. I will share just one slide on that. The advantage of Echion material is that in the market we can find a lot of people are talking about fast charging, solid state batteries, high energy density batteries. But the issue that no one is focusing a lot on safety. So safety is a lot of application. If safety is not there, we cannot put any batteries, for example, for train application, for e-mobility. So safety is something very important. Something very important for some application. And this is one of the advantage that our material is has the very safe in a very safe performances. Let's say in extreme temperature, we have done some nail test, and we have no fire, no explosion of the electrolyte. So this is one of our first advantages. Second one is the fast charge. So here our battery can fast charge. If you can see here, if I do a pointer, so here we can fast charge in less than 6 minutes. So what we found in the market usually is you fast charge about 30 minutes. So and also if you fast charge at these 30 minutes, you have safety issues because you have some dendrites in the graphite cells. So usually you will lose in cycle life. So what you propose is a material that can fast charge in less than 6 minutes and have very good cycle life. We have achieved more than 12,000 cycle, and you can find some paper, PR and white paper in our website as well on that. And maybe I will say another point is that some people will say, oh, okay, fast charging, LTO cells can do it, but the issue of LTO cells is the energy density. So we propose 2 times higher energy density compared to LTO cells. So yeah, so in summary, the unique proposition that Echion is doing is fast charging in a safe way with very good unique power capability and energy density. So this will be the summary on the unique proposition of Echion material.
Yeah, thank you, Loubna. It's good to know about the fast charging technology of Echion. Yeah. So Ravi, you can start second.
Sure. So what really, this is a common question we get from investors and even some of the customers. What really differentiates our products from others? Well, we are working on 3 main aspects. One, most of our e-bike batteries will be UL certified, so it is safe. It won't cause any fire hazards. And then second, it will have a really long lifetime. As you have seen, if you read the latest paper in the Journal of Electrochemistry, one from 2019, where Dr. Dunn showed that some of the cells can have really long lifetime, thousands of cycles. So currently, most of the e-bike batteries on the market use NCA, which is the Samsung 50E21700 cells made of NCA and then graphite or some silicon in it. And then people also use NMC 811. So people are not going to go to LFP when we want something lightweight. Applications like scooters and e-bikes, where weight is important. If it's too heavy, people cannot lift the bike. You cannot take it on the train or somewhere. So people want something lightweight, and that kind of negates the point of using LFP, because if you want to have a really good long range electric bike, then your bike will be like 35 kilograms, and not many people can lift 35 kilograms, put it on the rack and all of that. So people want something lightweight. Then we are looking at NMC 811. Now, if we can get 5,000 cycles out of it, then we can offer the same warranty as a Tesla or a Prius or Ionic or whatever, like 8 years. So that's the path we have. Currently, we will offer 3 years. And then as we bring some of these advanced single crystal chemistries, then we can offer, the goal is to offer 8-year warranty. Then people will say, oh, okay, I don't have to, you go to anybody and ask, what are the two biggest reasons you don't drive an electric car? They will say, first, it's too expensive. Second, I'm not sure, if I get a Honda or a Lexus or a Toyota, I'm pretty sure I can get parts and I can drive it for 10, 15 years. But if, I'm not sure with the battery, I don't know what the replacement cost is for an electric car. So this is even for people who are pretty knowledgeable about it. But the moment you start offering 8-year and then people see the return of investment within 2 years, then, oh, okay, it makes sense now. I can recoup the cost within 2 years and everything else is free. So long lifetime is what we're going to offer. And the third, lastly, we're building an ecosystem. You come home, suddenly your e-bike will become your backup. If there is a power outage, it will power your lights and just the essentials, not the washer, dryer kind of thing, just the essential devices. So some of our bikes will have up to 1.5 kilowatt hour capacity. That is good enough to power your refrigerator, microwave, lights, laptop, Wi-Fi router up to 7-8 hours. And the moment because you see in Waterloo, you may ride an e-bike or an e-scooter for 6 to 8 months. And then for the months, December, January to March and the end of April, most people don't ride in the winter months, especially in Canada, Wisconsin, Michigan, those places. So those months, you can use this as a backup system or even do something, something to offer, like maybe not like peak shaving, but it will be part of your home storage system. So that's the third one. So these three, long lifetime, safety certification, and then being part of this ecosystem of storage device will be our main technical advantage.
Thank you, Ravi. Thank you so much. It's a great, science, or I would say technology, which you're implementing in generating new electric bikes. That's good to know. So Chris, you can start now.
Sure. So I'll take it in maybe two parts. And from a recycling point of view on lithium-ion batteries, being biased, of course, we have some technological advantages with our spoke technology. For example, we can process any form factor, any state of charge battery, so we don't have to discharge. We do it at low temperatures. So when you look at our competitors, you'll find that some of them are doing high temperature processing. We don't do that. They have to discharge their batteries before they can process them. We don't do that as well. So there are technical advantages, and I think you'd get that in any of our competitors. There'll be positives and negatives to each company. Now, I think where we really shine, to be honest, is less on the technical side. We do have strong technical capabilities, but it's also the people. So my group will roll out technologies coming out of research and development, and without the people within the company to take that and to move it into capital projects and ultimately to commercialize those technologies, it really becomes an interesting R&D project. So what I focus on is the technical, but also building the teams around those technologies to be able to execute them well and actually make a business to grow and to change the industry for us, in that case, lithium-ion battery recycling. So technical is important, and I'll always talk technical, but it's also the people aspect for us that is very critical to how Lifecycle operates.
Thank you so much, Chris. Okay.
So Chris, that was you bring a very valid point, because you're doing your research, right? But you need to commercialize and make it a viable business, right? That brings me to my next question. As you know, our audience, most of them are lab researchers, right? So we are all wondering, like, what are the differences in a lab scale research and then bringing it into a commercial or making it a large scale process? Like, what are the set of challenges? So I will ask all of our guests to bring their perspective on this. So again, I think we can start with Dr. Loubna first.
So yes, so the challenge. So the question is about the challenge, right, of being in this market.
Bringing the lab scale processes to a large industry scale.
Yeah. Okay. So I think it will depend on the companies. However, from my experience at Echion as a startup, I will say it's very important to know the timing where should we scale to go from grams to kilos to tons level. So it's not that easy to decide, because usually if you have a customer, usually they would like commercial product, right? And in order to achieve this commercial product, it's like, but it's not yet commercial. It's just before doing, let's say, big scale up, you need to validate it that you have already a customer for that. So I think the challenge was when should we put the capability in order to produce a lot of quantities to scale up the material. And I think for that you need to have some to validate. You have your own, of course, research part and the marketing part, put a lot of things on marketing and try to find if there is any good market on that, to validate it with some customer and then do the scale up. The scale up itself, the process itself, I will say it's not that complicated. You have to the process team to find the right equipment for that. You have two strategy: you do it yourself internally, or you find another partner who can exist in the market, who can help you to do it.
Thank you, Dr. Loubna. I will ask Chris for his input.
From our perspective, that's where our technology started, was on the bench. There's a comical video that floats around Lifecycle where our first shredder for the battery processing was actually a blender with a battery in it, so that didn't go well, but that's learning, I think, and we've continued that culture within the organization. So we have our own lab facilities now that we do bench scale testing. We have our own pilot facility that we scale into, and ultimately we move into commercialization. And from my perspective, I think as you move along that spectrum, you get more and more complexity built into the system, and so things that work on the bench may not necessarily work as you expect in the pilot. And we've discovered filtration, for example, becomes an interesting scale-up challenge from the bench to a pilot and into commercial. So I think you learn more as you progress, but you also have to be flexible in the design that you propose for certain flow sheets. I'm being very vague, but in general, I think as you progress, you learn more, and you have to be flexible in the way you design, because you have to expect that things aren't going to go necessarily the way you think they will when you go from bench to pilot in particular. So I think there's challenges with that, but the best thing you can do is get dirty. And one of your questions, I think, further on will be, what do I think engineers need to be doing more of? And that is that getting dirty aspect. Get into a pilot and actually give it a shot, because you'll learn a lot.
Thanks, Chris. So basically, like reiterating and then learning from your mistakes and keep improving on your research or scaling it up. So Ravi, what do you think of this?
You mean the challenges in our space?
Yes.
There are three main challenges. One is the supply chain. Supply chain is such within our space. Anything to do with electric, the lead times are so high. You have seen what happened to Rivian's stock. You have seen what happened to some of the other companies. Building a company in the middle of this pandemic is like undergoing root canal and open heart surgery at the same time. It's quite challenging because there's war going on in Europe. There's lockdowns in Asia, and you need parts, and BMS chips are tied to electronic chip shortages. So it's quite challenging, but it will resolve over time. Second being, it is price sensitive. At the end of the day, somebody asked a question, what are the most promising cathodes? Well, it will be, for the mass market, it will be LFP, because people care about cost. At the end of the day, if an electric car costs $30,000, or $25,000, it will make a big difference. So cost is really important. So we want to manage cost and safety and then value proposition properly so business can scale up. And then third one is, as Chris mentioned, to really commercialize anything, you not only need technology, you need great people. Technology is just one face of the coin. The other face is you need great team to execute it and really commercialize it. So marketing, product awareness, creating product awareness, and really commercializing it. That's the hard, dirty work, hard work. It takes a lot of to commercialize it, get the value down to where the market is really accepting it, and then making sure you can stand out and at least build a sustainable business. So people, pricing, and then managing supply chain, these three are key in our space.
Thank you, Ravi. I will ask Vipin for the next question.
So yeah, that's a good thing to know. As Ravi mentioned in the previous question, that like someone like me who wants to buy an electric car, so like I have to think whether it is cheap or not. So the question is related to the same. So what is the most expensive part of the process with your technology, whether it is materials on which you're working on, or is it the manufacturing part?
So can you repeat the question again?
So I just wanted to ask you, like, what is the most expensive part of the process with the technology with which you are working on? So what cost you the most? What cost is you the most in that process?
I can begin. So
Yeah, sure.
yes, so for Echion, I will say the most expensive part, two parts in the company, I would say, because you have the material itself. So you have all the raw material that you do not have the power to change the cost of this kind of material. So there is the raw material itself. And the second part, I will say, is that not during the production of the material, but all the part of the marketing, convincing people of this new technology. So it takes you a lot of costs on that, I would say. Yeah.
So it makes sense. So yeah, Ravi, you can start now.
Sure. The most expensive part for us is, again, the battery pack, getting it to where it needs to be. It has to have all the certifications. It has to have all the testing done, and being able to. So if you're bringing this new chemistry, single crystal chemistry cathodes to the market, then you need a partner who can produce these cells in megawatt hours, hundreds of thousands of cells. And either you have to have scale, or you have to have deep pockets to I mean, both, they both go hand in hand. So getting the battery technology commercialized, it's no trivial task. That's our single biggest. And of course, as Dr. Loubna mentioned, you need to educate the customer. People will just go see what's on the Google search, top 3 lines. Oh, this is okay, let me try that. But maybe not many people know that niobium oxide may be a better option than LTO. So it is the marketing and also the education that goes into it, the amount of time you have to spend. So what we call as customer acquisition cost can be high in the beginning. So material cost, the cathode and battery pack, and also the customer acquisition cost, they're quite high.
Yeah, that's true. Chris?
I would consider us a growth stage company at the moment. So what we're looking to do is build out all the infrastructure, or the assets, if you will, to be able to recycle lithium-ion batteries. So I can't say that one aspect of that is the most costly, but from my view within Lifecycle on the capital project side, that's ultimately where we're spending our money, and that's building a spoke network that allows us to capture the market of end-of-life lithium-ion batteries and battery materials. And then also building out our hydrometallurgical plant here in Rochester. That's our next big capital project. We're in construction now, and that's we've released that publicly as $485 million. So that gives you an idea of sort of the scale of what we actually have to build, and that's a big hydrometallurgical plant. So you're talking tanks and pumps and solvent extraction and crystallizers. So all of those are very costly, and they're all related to material pricing and supply chain and logistics. So I don't have a defined answer for you, other than essentially the capital projects that we build are our biggest expense at the moment.
Yeah, thanks a lot. And just a quick reminder to the audience, like if they have any questions, they are free to post it in the chat box, and we will try to read it for them in the end. So Moin, you can go with the next question.
All right. So it's getting longer than we expected. The conversation is really lively, and I think we can go on forever on the technical and business. It's really interesting. But so let me just move on to career questions, right? So let's say if someone wants to join your team, what kind of skills are you looking for in an electrochemist or an engineer when you want to hire them? So again, I would start with Dr. Loubna first.
Okay, so that's very interesting question. So I think there is different profile that can fit in any company in the lithium-ion battery industry, so or the battery industry. So maybe if I focus at Echion, for example, we need material scientists, we will need research, we need process team. So we need electrochemical person to evaluate the performance at the cell level. So there is different project manager in each company. You will need project manager to follow all the different projects that we have in the company. Finance things. So I think if you would like to penetrate this market, this industry, there is different way to do it. And if it's specifically, if we talk about electrochemistry, you can be in the material scientist to synthesize new material, to look at the aging mechanism, which one is the best, of course. And the second part, it's all about the cell development. So the cell development at small scale and also at bigger scale. And this include also the process team as well.
What about Chris? What do you think? What kind of skills you think is important in general, and also for an electrochemist and engineer?
I won't focus on the technical skills. I think that base knowledge has to be there on the technical side. For me, it's a curiosity and a sense of entrepreneurship. So being curious in that what we do is is chemistry related, but there is no precedent at this point in time, or very little precedent. So being able to ask the right questions, to dig into the chemistry aspects of what we do, and then also to be entrepreneurial to the point where we'll just go and try it. So we have the facilities within the company to try things at the bench scale, at the pilot scale, and not being timid, I guess is maybe the right word, and being able to go in and actually try things, and again expand on your curiosity and learn, because that's where all of our technologies have come out of, is flow sheets that we've put together, but then also have gotten our hands dirty and just tried to figure out how to make it work. So that is something that I look for when I interview, is that sense of entrepreneurship there, is that curiosity there to just want to learn and to understand why things work.
Yeah, thank you, Chris.
Maybe if I can add, sorry, because I was focused on the technical part, yes. But yes, it's an important part, the soft skills. It's very important to work together, different culture, to work with different people in terms of personality. Each one is different, so we have to yes, to be able to work together. Even for a small company, it's very important, because it's this collaboration, this teamwork, which helps to achieve very good performances. And yes, I will add a lot of initiative for startup. If you need to have initiative, lots of initiative, someone who can, they do not need to hear from their manager what do they need to do, but to have their own initiative, to do their own job and to take responsibilities themselves.
Thank you, Dr. Loubna. Chris, it seems like technical skills is one area, right? But like soft skills, where you wanna be as a team and try like different things and try to validate your thinking. How about you, Ravi? What skills you think are important for your team, or what skills you're looking for?
To be honest, we look for somebody who is willing to learn, because we if you have the right work ethic, you can pick up almost anything. I've seen people with non-engineering background do pretty well in some cases, and then people with engineering background do pretty well in management side. So it comes down to, can you think in a certain way, and then are you passionate about it? If you're passionate about it, then it doesn't really take a toll. It doesn't feel like a drag. And if you feel connected to the topic, then you can put in the extra hour, you can learn new things. So being able to learn and having great work ethic goes a long way in success, especially in startups. You look at how Redwood Materials or even Tesla built, in the beginning stages, they had to get Panasonic cells, they had to use AC propulsions, motor system. They didn't have, at those days, everybody was using like 18650 cells. So you're doing everything new. So being connected and being able to learn new things can go a really long way.
Right. So again, with Ravi, like soft skills are really important, especially for a startup and a business. So I will ask Vipin for the next question.
So so I hope the attendees have gained a significant insight from the career advice given by our panelists. But now I want to lighten up our mood a little. So actually, I find it really interesting to hear what gets people excited about what they do. So what do you like the most about your job? So Dr. Loubna again, you can go first. We can't hear you, Dr. Loubna.
Sorry, I was muted. So I think the most, what I like in my job and what I liked all the time in my jobs is I was looking to have a great team to work with people. So if we don't like people to work with people, I think it will be difficult for some jobs, but it is the most important, exciting part for me. I work with people when I work in the internal with my team, with the different team in the company, but also as a team with customers. So customers as well, we have lots of collaboration. I have lots of collaboration with customers, and all the time is different team, different culture, different countries. So I work with US, with Canada, with Asia, with the French people, European people, and this is something I think. Something is very exciting for me. I'm originally from Morocco, so I went then after my my studies to finish my studies in France, and then I moved to different parts in France, and I come back and come to Cambridge in UK. So I think it's part of me to be in a different culture and work with different people.
Yeah, like it always feels good, like to being in such a profession where you can explore like several things together. So that's a good thing. So Chris, you can start now.
Maybe I'll answer it as the most rewarding thing that I've had over my career at Lifecycle anyway, has been watching the team grow. So when we started, we had our research and development team going, we were doing some piloting work, and we were quite small on the technical side. Over the last few years, we've grown very, very quickly. And so just to look back and be able to see how far we've come and what we've accomplished in the time frame is very, very rewarding. And so that's the part of my job that I really enjoy, is having that ability to look back and say, this team that we're growing is very technical, is very smart, and they're doing amazing things within the company. It makes me smile, that's for sure.
Thank you, Chris. Ravi.
So I agree with what Chris and Dr. Loubna said. It's every job has its rewarding and also some challenges, but rewarding, it's mostly rewarding. And in our case, when we get comments from our customers, we are getting some early customers. We have close to $500,000 worth of orders, and some of the customers are picking up their e-bikes, and then they send us images and, hey, look at this. I was able to go to my work today, and when I was going by this gas station, I was smiling and I had this great time commuting to work. And when we see that our products are really making a difference in the world, it's quite rewarding to see people say, hey, I was thinking of purchasing a car. Now I'm just going to use this until the end of this year, maybe release a car later on. So seeing that, it's kind of, satisfying.
Yeah. Thank you, Ravi. So I think before going to the audience questions, I would like to extend a sincere thanks to Dr. Loubna, Dr. Ravi, and Chris for their time and some great insights into their technology and lithium-ion batteries and their development. And I personally think that this is a really promising technology from what I hear now from you all. And we are really excited to stay tuned to know what will happen in the upcoming years. So I think this will be an exciting period for the lithium-ion batteries. So I think I can go to the audience questions now. I think most of the questions has already been answered. So
I would like to
Maybe,
thank the. Sorry, Loubna, I didn't mean to cut you. I was just going to thank the guests for answering these questions so actively.
yeah,
Thank you very much.
that's a good thing. So I think there is one question which is still unanswered, which is which methods, wet, chemical, solid combustion, are most promising for synthesis and on an industrial scale from your point of view? I think it's for Ravi and Loubna.
So I can go first, and then Dr. Loubna can add her point of view. From what I can see, anything that minimizes usage of toxic solvents, anything that increases the productivity rate. So there's a big push getting into solid synthesis. In fact, Tesla purchased Maxwell Tech, but then they ran into some issues. If you other companies too, for example, Volkswagen has been working with Scania in Europe about developing these methods where they can synthesize active materials without using solvents. So if we can do both positive electrode and if you especially positive electrode synthesis is challenging, and if you can do that without using solvents, toxic solvents that require baking and recycling on some of the complex methods, then that's, especially at the industrial scale, it's huge. Even if you scale, even if you save a couple of dollars for a battery, I mean, or it scales up really quickly, what I'm trying to say. So that's for the electrode, positive electrode. And then if we can manufacture solid state electrolytes at a lower cost, that's right now, there is so much push on solid state electrolytes, but the real pain point or the real crux will be to bring the cost of solid electrolytes on par with the current electrolytes. That's going to be really challenging, because we can some companies may make it for both earphones or AirPods, but when you start going into bigger electric vehicles like scooters and electric cars and storage, then you really need to think about.
Yeah, thank you, Ravi. Loubna?
Yeah, I think I agree with Ravi about yes, which technique is the best. It's complicated a little bit. It depends, as Ravi said, on solvent that you are using, on the production cost. So I think the production cost and sustainability, and safety, the 3 points, most important things. So depending on the cathode or the nature of the cathode or the nature of the anode, I would say depending on these three parameters, you have to study these three parameters in order to choose which one is the best, basically.
And Chris, what do you think is the most promising method for recycling?
So I'll be biased, of course. So I think we're kind of in the middle of cathode to cathode, as early as that is, and pyro. We're on the hydromet side, so of course I'm going to say hydromet is the most promising. But I think it does have its advantages, right? We don't have high temperatures. We use water-based chemistries, so I'll just maybe leave it there. But I am biased.
Okay, thank you, Chris. The second question is about, I think this question is for Chris, about the recycling strategy. So how robust is your process to handle batteries based on more recent technology? For instance, the battery composition of NMCs would likely be changing from cobalt dominant to nickel. And would NMCs remain the dominant battery, or there are any other types such as vanadium batteries at a risk?
A very good question. So the front end of our process, the mechanical process of the spokes, is agnostic to chemistry. It's a really a polite way of saying it is a deconstruction of the batteries down to its components. The hydrometallurgical process, is where the chemistry becomes important. So we have the ability on the front end, for example, to blend, so that we design our hydromet process to operate with certain feed chemistries. There's a range, of course, to that, but we're able to fit within that range quite well on the NMC chemistry side. So variations in nickel and cobalt and manganese we can handle. On the LFP side, that is a separate line for us. So we do have a patent application on an LFP processing system. It is a little different because you take out the nickel and the cobalt, of course, but for us, we're pretty flexible when it comes to chemistry. We can blend, we can handle different chemistry types. When we get into things like solid state, that's where we're looking now from an R&D point of view, is just to be sure that we're matching what's coming down, and we're judging that against our technology portfolio and changing as we need to. But at this point in time, we're quite flexible on the chemistries that are on the market right now.
Yeah, that's an excellent answer. Thank you, Chris. So I think it's this question is based on beyond lithium-ion batteries, I would say. So do you see other battery materials such as silicon being commercialized soon, and how do you think that might affect the battery industry?
So silicon is already in the market a little bit. So in the cells, we will find around 10%, maybe 20% at the cell level, not completely silicon, right? But it's part of silicon on the graphite side. So it's already a commercial part of it, right? However, to move to higher quantity of silicon, the challenge will be all the time about the cycle life. Cycle life, depending on the application, of course, the cycle life of silicon is very low compared to pure graphite with very low silicon content. So yeah, it's coming. I think people are working a lot on it, but it's not yet there, I will say, fully completely only silicon. Or it could be when you use the solid state electrolytes, the ACI or the challenge of the ACI around the silicon will be a little bit less. So it could be something when this solid electrolyte will be coming. Yeah.
Yeah. If you look at Sila Nanotechnologies and also Amprius is going to go big with their nanowire stuff, and also Sila has already gotten into wearable tech, and then they will be getting into Mercedes G-Wagon. They announced, which they announced recently. So something to look forward to. There may be some role in silicon because it's cheap, and if we can get rid of the swelling problem and get enough decent cycle life up to 2,000 cycles, then it can make a difference. So something to look forward to, Amprius and Sila and a few others.
Yeah, I think Sila Nanotechnologies, they are actively working on silicon-based anodes. That's good.
Right.
Yeah. So, Chris.
There was one question about, I think, which cathode is most promising. There was NMC, NCI, and LFP. Maybe I would like just to comment on that.
Sure.
So I think in the past there was a lot of NMC 111, which is people went for that because of safety compared to nickel rich, and now there was a lot of studies today on nickel rich in order to increase the content on NMC or even NCA to increase the energy density. However, when we see that the challenge of this cathode is the safety. So this, so we have seen in the last 4 years, everyone was going, let's do a nickel rich. But however, we had a lot of issues in safety, a lot of fire, and the people come back to LFP. So now the LFP is going on because due to this safety. So I think if we resolve the safety issues of the NMC and CA one, they can come back on. They can come back and take over the LFP, because the issue of LFP is still a high, very low energy density. So people as well are working on LFMP kind of cathode in order to increase the energy density, but maintaining the safety. So yes, so LFP, maybe we will have this next generation of LFMP, and then if we can resolve the problem of safety on NMC, NCA, NMC by maybe solid state or any other technique that's improved the safety level, we can see this cathode as well.
And yes, I totally agree with that. And yes, indeed, the LFP is free from cobalt, which is kind of main problem these days with the batteries. Yeah. So I think there are lots of questions in the chat box, but we are running out of time. So I think I cannot read them for you. So thanks again to all panelists, and many thanks to all other attendees for joining in, and hope you all have learned something new today about the startup journeys in lithium-ion batteries. Thank you so much and stay charged. Thanks a lot.
Thank you.
Thank you.
Thank you.
Thank you, Echion.
Yeah.